Hello and welcome to section 2.1a. In this section we're going to talk about quadratic functions, and we're just going to do a little review here at the beginning. The definition of a quadratic function is something that looks like this: ax squared plus bx plus c equal to either f of x or 0, just depending on what we're doing. But when we're dealing with f of x, it's a function. And so then what we're going to talk about here is the quadratic formula. And remember, the quadratic formula solves for x. When you don't feel like graphing or you don't feel like factoring, this one will work. The a, b, and c come from the a, b, and c up above up here. And you guys have seen this before. Hopefully you remember it, but make sure you write it down if you need to. Then from standard form, we also we have a standard form, or what we like to call vertex form, and the vertex form of the quadratic looks like this. And the reason it is called vertex form is the h and the k value give us the vertex of the parabola, where it is located on the coordinate plane. The a value, remember, is the multiplier, just like the a value out in front of the x squared of our function. It's the multiplier. It's basically how wide or how skinny the graph becomes. So we'll talk about this, and we'll talk about getting these as we go throughout this section. And so the first one here, our example one of the video notes, it says find the values of x when f of x equals 0 of this function. And so we're going to use the quadratic formula. You might be able to factor this, but since 5 is a prime number, the factors of 5 are 1 and 5, and therefore when I subtract them, there's no way I can get 2. So I'm going to have to go ahead and use the quadratic formula for this. And remember, this is basically, we're trying to find the value of x. And so we need what x is equal to. And if it's negative b, so remember the quadratic formula is this: negative b plus or minus the square root of b squared minus 4ac all over 2a. So we're just going to follow that. In this case, a is 1. The number in front of the x squared. B is negative 2. Make sure you keep track of your signs. And c is negative 5. And so following that form, we're just going to plug them in, and when we simplify that, we will get the exact value of where the graph is crossing the x-axis, or where f of x is equal to 0, which is basically our x-intercepts is what we're looking for. So if we go ahead and do this, we're going to say negative b, so 2, plus or minus the square root of negative 2 squared minus 4 times a times c. All that's underneath the square root. And this whole thing is over 2 times a, which is 1. So that's the whole thing written out. Now we just have to simplify it, and that's sometimes the challenge here, but we will go ahead and simplify. If I simplify negative 2 squared, that's 4, and negative 4 times negative 5 becomes positive 20, and on the bottom it's just all over 2. So if we just keep working here, we end up with the square root of 24 over 2, and in 24, the perfect square in 24 is 4 times 6, and so my perfect square is 4, so I can take the square root of 4 and bring that out, and so then we end up with 2 plus or minus 2 root 6. That's the same thing as 24, all divided by 2. Now, since both the 2 out front up here and this 2 in the back are both divisible by 2, I'm gonna divide them by 2, and then I'll get rid of my fraction. So I'm really left with x equals 1 plus or minus root 6. And so remember, this is two solutions. It's either x equals 1 plus root 6 or x equals 1 minus root 6. And if you need to know what those numbers are, you can put these into your calculator to approximate where they're crossing if you had to graph them or something like that. But that's the quadratic formula. Hopefully that you remember that. Then we are going to put these two guys in vertex form. It says find the vertex in the line of symmetry. So, well, if you notice, or if you remember from vertex form, we said something like f of x equals a times x minus h squared plus k. Well, if we look at this, you can see this guy's already in vertex form. The a value in this case, and so it's just a matter of picking this apart, the a value is 2, which really has nothing to do with the vertex, but I just wanted to point out that it's there. We have that our h value, the opposite, because it's a negative in here, so the h value in this case is the opposite of 5, which would be negative 5, and then the k value looks like it is the opposite of 2, which looks something like that. So we are looking at our vertex of our parabola at -5 and -2. Now, if I was to kind of quickly sketch a graph of that, I would be going back 5 and down 2 to get the vertex of my parabola, and from there I could sketch my parabola something like this probably. And so what we're talking about here, that's the vertex by the vertex form, but over here we're also asking for the line of symmetry. And the line of symmetry in this case is a line that my drawing doesn't do it very much justice here, but my axis of symmetry is a line that I could fold the parabola along that would lay one half on the other half. So I could fold this in half. So basically, when I'm asking you for the line of symmetry, I'm asking you for an equation, and the equation will be where the graph will be going through the vertex every time. And so if you notice, this is a vertical line, so we're looking for an x value, so the axis of symmetry is the x value of the vertex, and that would be -5. So that's my axis of symmetry. And up here this is my vertex. So then we'll try the same thing. I would pause it and try it on your own, and then see if you can get the same thing I've got when we do this. So my vertex in this case, my h value is the opposite of what I see. So it is the opposite of 3, so that's +3, and k happens to be +1. So my vertex of my parabola is at 3 and 1. My axis of symmetry is basically going to be dealing with the vertex, and so we'll do a quick sketch just to kind of give you an idea. I'm going to go over 3, up 1, and since it's a -1/2, the parabola is going to go this way, and it's going to be fairly wide. And so I get something like that, and my axis of symmetry would be this vertical line right here. And so hopefully you can see that the vertical line, the axis of symmetry, is at 3, so that would mean that I'm dealing with x equals 3. And if you'll notice, it is always the x value in my vertex is the axis of symmetry. So then we want to rewrite this equation in vertex form, and then we're going to identify the vertex and the axis of symmetry. So in order to write it in vertex form, we have to do what we call complete the square. And you've probably done this before. If you haven't, that's okay, but I'm going to try to walk you through this a little bit to complete the square. What we do is we want to turn this part right here, the x's, into a perfect square, because our goal is this, to get a function that looks like this, the vertex form. We want it to look like that, so we need a perfect square binomial that when I square it will get me something that gives me this. So in order to do that, what we have to do is we take our b value and divide it by 2. So we take b and divide by 2, and that will give me the number. So I'm going to just write it as b divided by 2, and then we'll always square that number to get the number that we're going to add on to this function. So we're going to add that on. So when I go ahead and do my completing the square, I'm looking for a missing term, x squared minus 2x. I'm trying to add something on to my function. I just kind of space it out and push the 5 down. So now if I take that middle term, -2, and divide it by 2, I get -1. But I got to square that -1, and remember I want to square the negative also, so I get +1. So I'm going to add +1 to my function. Now by adding +1 to my function, I have changed the function, because now this last term is -4 instead of -5. So I have to keep this function in balance, and so whatever I add on, I also need to subtract away. So I'm adding 1 on, I'm going to subtract 1 to keep my equation in balance. That way I end up with still a -5 here at the back end. So this stuff, this first 3 terms, is something that should be a perfect square, that if I factor it, it will get me something that looks like x minus h squared. And then this last, I'm going to kind of clean that up. The -5 and the -1 go together, which would get me -6. So hopefully you can kind of see the vertex form showing up a little bit. And if I go ahead and factor this, let's see. I'm multiplying to get +1. I'm adding to get -2. So that means it's -1 and -1. So this guy will factor out to be x minus 1 times x minus 1 minus 6. And so since these guys are the same, we don't need to write it like that. We can write it as a perfect square, which gives me x minus 1 squared minus 6. So there is my parabola, my vertex form of my function. The a value is a 1. It's hidden out there. And so now we're just going to go ahead and pull apart, get the h, the k, and the axis of symmetry from this graph. So you'll notice that my h value here is -1, but it's always the opposite, because you can see that it's negative h in there, so it's the opposite of that. So the h value in this case is +1, and my k value is -6. So my vertex, which is where I'm going here, the vertex of this would be 1 and -6. So that's one of the things we were looking for. We did all of this completing the square to get the vertex. Then we can also go ahead and find the axis of symmetry from this. And if you remember from the previous slides, you could do a quick little graph of this by going to the right 1 and down 6. It would end up giving you something, a parabola that went down like that, and then I could draw my axis of symmetry in through the vertex. And I kind of missed that line, sorry. But my vertex is here, so you can see that my axis of symmetry should be at +1. So axis, the axis of symmetry, is at +1, is x equals 1. And so that's what we're trying to do when we're dealing with these problems. So if you have any more questions about these, please come to class prepared to ask them. We will talk about them before we start class.